want to find the zeros of the polynomial x cubed minus 5x squared plus 2x plus 8. And to do so, I'm going to get started by using the rational. And the rational zero test says that if this polynomial has any rational zeros, they're going to be of the form p over q, where p is a factor of the constant in the equation. So that means that p would be a factor of 8, and q will be a factor of our leading coefficient, which is 1. So the factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and the factors of 1 are just plus or minus 1. So anything divided by 1 is itself. So if this polynomial has any rational zeros, the possible rational zeros are plus or minus 1, 2, 4, or 8. So to get started solving the equation, we're going to synthetically divide until we find one of these possibilities that will work. And we're going to know it works because it will give us a 0 as our remainder when we synthetically divide. So I'm going to take the coefficients in my polynomial, 1x cubed, negative 5x squared, 2x, and 8. And I'm going to start going down my list of possibilities until I find one that works. So I'm going to start with negative 1 and synthetically divide, bring my first term straight down. Then I'm going to multiply. Negative 1 times 1 is negative 1. Add it to the next column. Negative 5 plus negative 1 is negative 6. Multiply again. Negative 1 times negative 6 is 6. 2 plus 6 is 8. Negative 1 times 8 is negative 8. 8 plus negative 8 is 0. So I obtained a 0, which tells me that negative 1 is one of my zeros. And that comes from the factor x plus 1, which when you set equal to 0 will give you x equals negative 1. And it also tells me that the other factor is the leftover part in my synthetic division problem preceding the 0, which will stand for x squared minus 6x plus 8. So if I'll factor x squared minus 6x plus 8, I will find my other two zeros. X squared minus 6x plus 8 is going to factor into x minus 2 times x minus 4, which will give us x equals 2 and x equals 4. And those then are the three zeros of this polynomial. If I want to write my polynomial in factored form, I will have f of x equals x plus 1 times x minus 2 times x minus 4. Can also note that the degree of my polynomial was 3, and we did indeed end up with 3 zeros. So that is how we can use the rational zero test to find all of the zeros of a polynomial, provided that they are rational.